Today we're going to be proving the arc of hyperbolic sine is equal to the natural log of x plus the square root of x squared plus 1. In our previous video, we found that the hyperbolic sine's definition is equal to e to the x minus e to the negative x divided by 2. I'm going to assume this quantity's outcome to be equal to a. So, from this equation, we can find the x quantity. The x quantity will be equal to the arc of hyperbolic sine of a to get the variable of x. This is similar to how we can find it in natural trigonometry, just regular trigonometry, that is. So sine of 30 degrees, for example, is equal to 1 over 2. So that means the arc of sine, 1 over 2, will give us 30 degrees. This is likewise in hyperbolic trigonometry. And for now, we're going to be analyzing e to the x minus e to the negative x divided by 2 is equal to a. We're going to analyze this equation for now. We can multiply 2 on both sides to get e to the x minus e to the negative x is equal to 2a, and defining e to the x to be equal to n. We did this because later in the proof, we're going to be relating this equation right here to a quadratic function, likewise to a quadratic equation. So we can substitute our n quantity for e to the x power, n minus n to the negative first power is equal to 2a. N to the negative first power is equal to n minus 1 over n is equal to 2a. We can combine n minus 1 over n to get n in the denominator and n squared minus 1 in the numerator to be equal to 2a. Multiply n on both sides to get n squared minus 1 is equal to 2an. Subtract 2a on both sides to get n squared minus 2an minus 1 is equal to 0. And n squared minus 2an minus 1 is equal to 0 is written in the form of a quadratic equation, which is ax squared plus bx plus c is equal to 0. And the quadratic formula states that the variable of x can be found by x is equal to negative b plus minus the square root of b squared minus 4ac divided by 2a. We can do that and solve the variable of n. The variable of n will be equal to n squared's coefficient 2a, or a is equal to 1, 2 in the denominator, and negative b, the quantity of b being equal to negative 2a in this circumstance. Negate that to get 2a plus minus the square root of b squared, 4a squared, minus 4 times negative 1. Negate that to get plus 4. We can factor out the square root of 4 from the square root of 4a squared minus 4 to get n is equal to 2 in the denominator, 2a plus minus 2 times the square root of a squared plus 1 in the numerator. This will be equal to, divide 2 for the two terms in the numerator is equal to a plus minus the square root of a squared plus 1. And remember our assumption. We assume the e to the x to be equal to n. We can now reapply e to the x back into the n variable to get e to the x is equal to this quantity right here. And to find the variable of x, we must take the natural log of this quantity. But before we do that, we must analyze this quantity, whether we keep the plus or the minus symbol. E to the x power, x, whether that be how small, such as 0.001, or how big, such as 1,000, e to the x, this quantity's result will always be greater than 0. E can be equal to a negative number as well, say negative 3. E to the negative third power will be equal to 1 over e to the third power. This will still be greater than 0. So x to any power, no matter what variable of x, negate or positive, e to the x will always be positive and greater than 0. Because of this, a minus the square root of a squared plus 1 will give us a value that's less than 0. Remember, excuse me, the square root of a squared plus 1 is greater than a. It could be negative or positive. The square root of a squared plus 1 will always be greater than a. Therefore, we cannot have the negate sign within a plus minus the square root of a squared plus 1, because if we do remain the negate sign, this will not be true and will not be equal to anything. It will be a false equation. So e to the x will be equal to a plus the square root of a squared plus 1, not minus. And then from here we can take the natural log to find the quantity of x. So x will be equal to the natural log of a plus the square root of a squared plus 1. And remember our this function, this equation right here. X is equal to the arc hyperbolic sine of a. Well, that x is the same thing as this x right here that we have solved for to be the natural log of a plus the square root of a squared plus 1. Therefore, we can substitute this into this equation, which I'm going to be reboxing in this green color. So, the natural log of a plus the square root of a squared plus 1 will be equal to the arc hyperbolic sine of a. So the arc hyperbolic sine of a. And we have proved the formula for the arc of sine, which remember we tried to prove this right here. And hence we proved it as true.